Hi, and welcome to my third academic paper video presentation for the paper Complex 529. In this presentation, I'll be talking about the paper called Enhancing Human-in-the-Loop Adaptive Systems Through Digital Twins and VR Interfaces. The authors for this paper are written below, and they're from Paderborn University in Germany. This paper was presented in the 16th International Symposium on Software Engineering for Adaptive and Self-Managing Systems, which was hosted in Madrid, Spain. So self-adaptation systems usually rely on closed-loop controllers that avoid human interaction. But there are many situations where human involvement is beneficial or even necessary. And this involvement can be added in many ways, in many areas in the MAPE-K loop. For example, the human could act as a sensor to observe things that are difficult to monitor, or as a decision maker to provide better insights on the best ways on managing a system. Humans can also provide knowledge that can be difficult to digitalize. And finally, humans can also act as actuators to make change on the system. This paper that we're going to talk about today works on the gap of self-adaptive systems being closed from human interaction. For human-in-the-loop adaptive systems, there are many challenges. The researchers have identified two main ones: transparency and controllability. Transparency is required to provide the human with feedback, explanation, and visualization about the system state and its context to establish and keep the human's trust and spatial awareness. Controllability refers to the ability for the human to control the self-adaptive system. The degree of controllability needs to be considered, and it needs to be in a natural way. Creating a way to incorporate humans in self-adaptive systems which can solve these main challenges is what the research paper looks at solving. Work in this area has identified that there is benefit in self-adaptive systems with the use of human interventions. There is also research that states that the systems need to keep humans in the loop to gain their trust of the user by providing feedback or transparency about the system state. In previous work, the concept of digital twins have been used in several domains, such as manufacturing or assistance systems. VR interfaces have been used in different application domains such as training, education, and healthcare. Utilizing a combination of the concept has also been demonstrated in previous work such as healthcare. However, despite the benefits of having humans in the loop, the optimal degree or the best way of incorporating humans to maximize system performance is still an open field of research. The main idea of this research was to implement and analyze two different human-in-the-loop strategies in VR. The first being a procedural control, where the human can control the decision-making process through VR. The reason for using VR instead of a regular graphic user interface is that virtual reality allows a user to observe the system in 3D and allows for more interaction. Procedural control allows the user to interact directly with the arm. The second strategy is to use declarative control, where the human specifies the goal state through VR and the robot attempts to match the state using an external AI planner. So both of these different strategies were created and tested in this research paper. The figure we see on the right is a figure from the research paper, which shows how this project demonstrated these strategies into the MAPE-K loop. So we can see that the project has utilized humans as a user to interact with the MAPE-K loop and implement change into the real world. The VR interface uses the Oculus Quest VR headset and the Unity game engine to create a 3D model of the robot. To be able to obtain the states of the robot and the cubes, the VR interface communicated with the robot operating system that manages the robot. Both of the control methods being tested in this research paper are a form of incorporating humans in the loop and have successfully been able to be both transparent and controllable. It is transparent through the digital twin, which is visualized by the user in the VR headset, and also controllable through VR technology, which allows the user to make changes in VR and that actually affects the real system. To evaluate the two different strategies, they ran a user evaluation through experiments. The two different control tactics, procedural and declarative control in VR, were evaluated to see which was more efficient, effective, and left the user more satisfied. The task given for the user was to pick up cubes with the robotic arm and align them in a specific order, using both control strategies. The times to complete the task were recorded, and it was found that the declarative control took a lot less time, and through user feedback, it was also easier for the user, leaving them more satisfied. This research paper provides a solution for enhancing human-in-the-loop adaptive systems through digital twins and VR interfaces. They've also evaluated two different strategies for applying this technology and have found that declarative control could be easier in some circumstances. Although in this research, the way that they evaluated the technologies was limited and it was tested in an intuitive task, whereas the digital twin technology is usually utilized in a more complex scenario. So there's still a gap where more research can be done for wider applicability of the main idea. Thank you for watching.